Let's take a look at prime factorization. In this video we're going to take a look at how to come up with the prime factorization of some example numbers right here. The key with prime factorization is that we're going to break up a number into prime factors. So pulling it apart as much as we can so that all we're left with is prime numbers which are multiplied together to get that number. It'll make much more sense as we get into it here. Though probably the easiest way, I think, to come up with the prime factorization is to use a factor tree. And a factor tree, we simply break the number that's above it up into two pieces. And these two pieces can be any numbers that multiply together to give this number. So in this case, I'll choose 6 times 6. 6 times 6 will get us 36. Then I'm going to go down my branches, and 6, can I break that up into anything? Is there anything multiplied together besides 1 and 6 that gets me 6? Well, sure enough, there is. 2 times 3. So I've got 2 times 3 there. Now, when I get to a point where I can't break 2 up anymore, the only thing that gives us 2 is 2 times 1, I'm at the end of my branch there, and I'm going to circle that. That's one of the prime factors that make up 36. Same thing with 3. There's no number other than 1 and 3 that gets us 3 for multiplying, so that's a prime number as well. Here this 6 is the same thing, 2 times 3, so we've got 2 times 3 like so. Then finally, I can write my prime factorization using exponents, and I have two 2's that are being multiplied, so it's 2 squared times 3 squared as well, because there's 2 of those. Now, this number right here, if I were to multiply this out, should get me back to what I started with. So let's try it just to be sure. So 2 squared is 2 times 2, which is 4. 3 squared is 3 times 3, which is 9. 4 times 9 is indeed 36. Now, sometimes people wonder, well, what if you would have chosen to break 36 up into 4 times 9? Would we have ended up with the same prime factorization? Let's see. If we would take 36, break it up into 4 times 9, then we've got 4 here. 4 breaks up into 2 times 2. And again, 2 is a prime number, so I've got to stop with those. Over here, the 9, that'll break up into 3 times 3. And here we are. Again, they're in a little bit different order, but it's the same numbers. 2 squared times 3 squared. So the prime factorization is the same no matter what numbers we choose to break up, as long as we keep going until we end up with those prime numbers at the end of our branches. Alright, so let's try this one right down here. 125. Well, I know that 125, what can I multiply together to get those? 25 times 5 would get me 125, so I'm going to start with that. 5's a prime number, so that piece is done. Then 25, well, that'll break up into 5 times 5. Again, we've got 5's there that are all prime, so my prime factorization of 125 is 5 to the 3rd power. Again, that would get me back to 125 if I were to multiply that out. Alright, let's take a look at 80 over here. So we have 80, we can break that up. Let's how about 8 times 10. Okay, again, we could do it in any number of ways. 2 times 40, 8 times 10, 4 times 20. All those would certainly be okay. And then break up that 8. Well, 4 times 2, how about? 2 is prime, so I'm going to circle that. 4 breaks up into 2 times 2. So I've got those 2's there. And then over here, the 10, that'll break up into 2 times 5. Okay, so let's figure out what we've got going here. We've got 1, 2, 3, 4 2's. So that would be 2 to the 4th power. And then times, there's that 5, so 2 to the 4th times 5. Alright, again, we could multiply that, get back to 80. Finally, let's try this one, 52. So, break it up. Let's go 2 times 26 for this one. And 2 is prime. Then 26 breaks up into 2 times 13. 2 is prime. 13 is also prime, so I'm done there, and we're left with just 2 squared, because we've got 2 times 2 times 13. Okay, so prime factorization allows us, or what we're interested in, is writing a number just using prime numbers, and oftentimes it's going to involve powers here. So hopefully this video was helpful. Factor trees are awfully handy when you're doing prime factorization, and I know you can do this stuff. Keep working hard on your math.